Yes, good morning, everyone. Hello, welcome to this webinar, Renewable Power to Heat. My name is Edwin Koot. I'm CEO and founder of Solarplaza, and it's an honor to present you this webinar with some interesting speakers and content. A little bit about my background. I founded Solarplaza in 2004. I've been in the solar industry since 1994. And yeah, I'm looking forward to this innovative, I would say, topic, which I have high expectations that in the near future, power to heat is going to be a very important concept that will thrive further the solar market. So a little bit about Solar Plaza. We're based in Rotterdam. We've organized over 200 events, hundreds of webinars, and we like sharing knowledge and network. That's our mission. In the end, to positively impact the world by accelerating the sustainable energy transition. We have a huge network. We organize events around the globe. We have a couple of events coming up, as you can see in this overview. And if you're interested, you can always challenge us and ask us for a partnership, because we also do a new service called Events as a Service. So we can organize webinars and events for you as an organization to help you sharing knowledge and network. So some practical notes on today's webinar. Questions, you can use the chat box, which you find in the menu. And you can also address technical issues in that chat box. And to be sure, all presentations and the slides and recordings will be made available after the webinar in 1 or 2 days after this little show. You see a nice background with me. I'm in the office. I'm not in a top bar in Santiago de Chile, but nevertheless, very welcome the other participants. And we have two interesting speakers for you today. First, we'll have a presentation by Arina Anisie. She is from IRENA. And after that, we'll have a presentation by Guy Win Stanley. And he is from Caldera. And we will have time after that for Q&A. But if you have a pressing question after each presentation, we'll make a few minutes available to address these questions too. So, having said that, let's go straight to the topic, into the topic of power to heat with the first speaker. And Arina is an analyst at IRENA, an energy expert working already for several years, 7 years for IRENA, and different innovative topics. And prior to working for IRENA, she worked at PSR Energy Consulting and Analytics, a Brazilian-based consulting firm. So we can get started. We'll give you the control over the mouse, and then you can take it away with your presentation. Please go ahead.
Thank you, Edwin, and hello, everyone. I'm sorry for this little hiccup. I don't know what happened, but I'm glad you can hear me well now. My name is Arina Anisie, and I'm working for IRENA. IRENA, just for who is not familiar, the International Renewable Energy Agency. It's an intergovernmental agency. It has 168 member countries, so it's quite a global organization. And our main role is to support and advise our member states in the energy transition based by renewable energy. So our main audience are policymakers. Its headquarters is in Abu Dhabi, in United Arab Emirates, but I am located in the Innovation and Technology Center, which is IRENA's office in Bonn, Germany. So I would start this presentation with a very big overview of the energy transition and a few numbers of where and the big picture, let's say. So based on IRENA's analysis, we see that electricity becomes the main energy carrier in 2050. Here on the screen, you see two blocks. One is on the left side is the total final energy consumption in 2018 and how was the mix, and on the right side in 2050 where we need to be if we want to be a Paris line agreement and to reach 1.5 mitigation scenarios. And we see that electricity becomes a very important player, replacing oil, natural gas, and coal, and 90% of this electricity will be covered by renewable electricity. Also, we see the hydrogen, it's increasing its role a little bit, and heat as well from actual numbers. What does it mean? It means that there will be a lot more electricity needs for the power system. Here we see the total demand and how much the electricity demand increases. And we see that it's driven basically by the production of hydrogen, the new electricity that will be required by the mobility sector, and also a big chunk, it's also the heating, the electrifying heating, power to heat. Just you can see here a number of comparison, the electricity that will be needed globally for production of green hydrogen, it's actually equal to what we consume today as electricity. So we need much more electricity. That can pose a very significant strain on our power grids as we know them today. So that's why in IRENA we try to emphasize a lot on the importance of smart approach and how to do it in a smart way, smart electrification, in order to also use it as a demand side management. So this new electricity load to provide the flexibility to the grid, to incorporate even higher share of wind and solar in the systems, but also to defer unnecessary investments in the grid. Our smart approach requires systemic innovation. And what we mean by systemic innovation, we mean that innovation is needed beyond technology. Innovation technology is very important, but to have practical on-the-ground solution, we also need to innovate in market design and regulation, in how the system planning and operation is done, and also to innovate in the new business model so we can create new revenue streams. And this is what we call systemic innovation approach. And we have released last year our flagship report on innovation called Innovation Landscape for Smart Electrification, which identifies 100 key innovations in these 4 pillars that I explained before, that guides policymaker in creating a smart strategy for electrifying the mobility sector, electrifying heating and cooling sector, and smart production of hydrogen. And today, in today's, just to say, this report, it's available on our website, also free of charge. Anyone can take a look. And for today's topic, I will focus on the section on power to heat and cooling of this report. Well, talking about power to heat, heat it's yeah, it's different. We use different technology depending on the temperature and scale of temperature needed and scale of applications needed. So here we map a little bit where heat pumps, we focus on heat pumps in the report, but where do they stand in comparison to heat needs in general? So heat pumps cover especially from 0 to 100 degrees temperatures. Then we have high temperature heat pumps, and then we have very high temperature heat pumps that can reach up to 300 degrees Celsius perhaps, but they are under development and research. And then we have industries that need much more temperature, much higher temperature than that. And for that, there are different solutions that emerge, such as e-cracking for chemical industries, or solar clean for cement industries, or different innovations. But in our report, we focus especially on 3 segments: district heating and cooling with medium large heat pumps as the main technology, building sectors with smaller heat pumps, and industry sector where we look more at high temperature heat pumps and also other technologies that can help with even higher technologies, higher temperatures, but are not yet fully commercial or they are more underdeveloped. But heat pumps are key for electrification of building and for power to heat when we talk about lower temperatures because they are highly efficient. They provide the heat requirements in buildings actually, and they also have reverse mode for provision on heating and cooling. So we see prospects for heat pump are huge. Today we have electricity share in buildings at 34%, but we need to increase to 53% by 2030 and for 73% in 2050. So that means much more heat pumps deployment in the buildings. For example, in the number of heat pumps, IRENA study says that today we have around 58 million heat pumps deployed, and we need to reach by 2050 almost 800 million. So a lot more deployment of heat pumps in the buildings, but also in the industry, as you can see, from less than 1 million today to 80 million in 2050. Also, of course, with the development and further improvement in higher temperatures heat pumps. Heat pumps are also becoming more and more competitive. We see that there are relevant cost reductions in the markets on heat pumps. Also, that heat pumps can benefit enormously from economies of scale. Here in this graph, you see how the cost in existing buildings and new buildings in Germany drops from smaller heat pumps capacity to larger capacity of heat pumps, and we see significant decrease as bigger as heat pumps. So economies of scale is an important factor. And also, there is no big difference in the cost of heat pump in new buildings and existing buildings. So electrifying and retrofitting the building from electrification of the heat, it's not a big difference in the cost, as can be a misconception. But we're not talking about the envelope and the increasing of energy efficiency of the building. From the market's point of view, we see that heat pumps are experiencing a stunning growth in major markets. Here we have a graph from European Heat Pump Association on the evolution of heat pumps in Europe. We see heat pumps market in Europe increased 34% between 2021 and 2022. But outside Europe as well, heat pumps are picking up. In China, in 2018, 48 million room air conditioners were sold, and also heat pumps saw an increase in the last years. In Japan, already 86% of households have at least one room air conditioner unit. Japan is probably the region with most heat pumps. And also in US, we see heat pump reach almost 4 million in 2021, which is more than twice than what was in sales in 2010. Yes, coming back to the systemic innovation approach, here with what we identified in the report, the 35 key innovations that we show to policymakers that these are important for creating a smart electrification strategy for electrifying heating and cooling in their countries. And as I mentioned, we identify innovation in technology and infrastructure, but it goes beyond that. And also innovation in electricity markets are important to give the incentive to operate the heat pumps in a way that doesn't overburden the grid, but can also provide some flexibility. Also, sector regulations and incentives are important, and here we look a bit on the importance of energy efficiency for savings and the standards and building codes and streamlining procedures. Integrated planning to plan because now we couple the heating sector with the electricity sector, so integrating planning of these two sectors is very important, and also a smart operation of these two sectors together. And on the business model side, we look at different services that the heat pumps can provide to the power system and can receive remuneration for that. Waste heat recovery models are very important to increase efficiency, and also different models to enable deployment. So I will not go one by one, but this is the list of 35 key innovations that we identified in the report, and we kind of signal that these are important for policymakers to look at the whole picture when they want to smartly electrify the heating sector in the country, and to make sure that elements from all this to have a practical on-the-ground solution are important. And here it's a little bit a toolbox that we offer to guide policymakers on how they can combine these 35 innovations. So the toolbox, it's made with an essential kit that basically shows what are the innovations they should look at first, wherever they want. The first step is to have these technologies in place, to have this market design and regulation. These are few innovations that are important in to be implemented from the beginning. System planning and holistic planning for cities, aggregator. These are few innovations that are important from the beginning, because of course they don't go through the 35 innovation at once. There are also steps, and ones come later, ones come depending on also of the low-hanging fruit, but there are few that are in an essential kit. And then depending on their strategies, whether they want to look more at buildings, at heating for industry, or district heating, there are different set of innovations that we recommend. These are for heating for buildings, where there are smaller heat pumps, hybrid heat pumps maybe for a better transition, and yeah, few other innovation. Again, I will not go one by one, but I just want to show that it's very important to look at the scale and the temperature of the heating in order to have a targeted strategy for it, because not only the technology differs, but also how you operate and what are the incentives that are needed. And this one is the toolbox for heating for industry, where you have a little bit less decentralized loads, but more centralized loads, more different flexibility potential comparing to the households in the industry. They are coming from industry processes. So the strategy itself, it's indeed very different. As well, we have a cooling kit, but I will not go into that today. This is my last slide. I want just to end with few important points that we see as blind spot for policymaker, and we try to shed some light into this. One is again to mention that the temperature is critical variable in designing smart electrification strategies. Hybrid heat pumps are often overlooked, but they actually offer an interim solution to rapidly introduce heat pumps in buildings with existing gas infrastructure. So it's something also to consider. Thermal energy storage has significant potential to increase the power system flexibility. Digitalization, it's at the core of the smart approach. Communication between devices, collecting information, this is key. The cooling demand is growing also with the increase in temperature, and should be considered in energy planning. There are also a lot of synergies between the cooling demand and the solar electricity production. So this is also interesting to harness it. Building codes offer important incentives for a smart heating strategy in residential sector. So just to put emphasis on building codes. And of course, energy efficiency, waste heat cold recovery should be a key part of smart electrification strategy. I would like to end here, and I'm looking forward also for your questions and for hearing from on the ground how these are implemented on our next
All right.
presentation.
Thank you, Arina. If all goes well in technology, you can hear me, right?
Yes.
Yep. Good. So I have a few questions from my side, if you may, if you allow me. So first, the heat pumps, as you showed, yeah, the market is going to grow tenfold in up to 2030 already, from 58 to 400 something, or almost 500, which is a huge increase. So where would you see the biggest part of this this increase taking place? Is there a specific market or region where you see this happening?
So the number I presented, it's not a projection of what we see that will happen. It's basically what needs to happen to be aligned with Paris Agreement. So it's a top-down analysis where we need to be in order to be Paris Agreement aligned. Heat pumps have a very important role whenever for the heat demand. No, so especially in northern a part of the globe, Europe, US, where we have colder temperatures in winter. I think there it's where the main heat pumps demand will grow for buildings. Then we have
Yeah.
also industry. Yeah.
And is there a market or other markets in Europe that are taking the lead with the application of heat pumps? Can you say something about that?
Yes, I actually want to go a few slides back because I have regarding market in Europe, remote control. I have this graph from European Heat Pump
Yeah, yeah,
Association that shows very nicely who are the leaders in Europe. So France, Italy, um, yeah, are Sweden and Germany are probably the top four leaders in developing heat pumps in 2021, but I think the trend maintains and grows. But in general, we see a big chunk also from all the others as
yeah.
aggregating. Yeah.
And if you look in the coming years, which market segment would you think will really grow? Is it residential or is more commercial and industrial? Where do you see biggest growth happening?
So as I mentioned, it in terms of cost, it makes sense to take advantage of the economies of scale. So commercial uh, and also district heating or bigger heat pumps are much more cost competitive than very small heat pumps. So that
Okay,
that is.
good.
I just had one more slide. I don't know if there was
My colleague is working on technology on the background to make it give you control
to
again.
make it happen. Yes, I
Yeah,
wanted. There was here I put some QR codes for the audience if they want to go to the report directly, and also we had a very interesting event last September, Innovation Week in Bonn, and all the summary and recordings are on our website if you want to go. We also had a session dedicated entirely on also electrifying heating and cooling in buildings. So if you want more information of our work and also hear from other experts from around the globe, it's also a great source of information, this summary and
okay,
recordings, just
very good. Yeah,
for record.
we will include this slide in the slide deck so that no rush for people to take their phones out and make copies of this QR code. It will be in the slide deck that will be shared with you afterwards. Thanks again,
Thank you
Arina.
very
Please
much.
stay with us before we go to the next speaker. Actually, I almost forgot that we want to do a little Slido question is to see who's in the room actually participating here today. So I kindly ask you for some participation and get a little active and just answer these two questions. First one, what is your status and how are you doing or already working with power to heat so far? Is it no, this is my first time exploring the topic and opportunities, or did you already dive into the topic, ready to learn more, or are you even having or offering services and products already in this market in power to heat? So when you join us in this webinar, it gives us some idea also for the next speaker, what is the background of our audience. So it seems like a majority of people already have dived into the topic before, and only like 25%, 1/5 of the audience is really first time in this topic, 10%. Okay, good. That gives us some idea of what is the audience, and maybe the next question. What is your background? So what is your position in the market, in the value chain? Are you in project development, in finance, or research and consultancy? Maybe in software, AI, and these kind of things, or in asset management. Nice for us all and for the speakers to have a little information of who's joining in this interesting webinar, who's exploring more in the opportunities of power to heat, and almost equal division. Surprisingly, very few or no people from the software side, where everything is going to be digitized in the near future. Maybe these people still need to wake up for this topic. But nice to see that majority is in project development, contractor, or EPC. Financing almost 25%, and 1/5 research consultancy asset management is 50%. Okay, thanks for your cooperation. Very nice. That will bring us to the next speaker. And now we're going to dive more into the practicalities and business cases. I'm very pleased to welcome Guy Win Stanley. He's the co-founder of Caldera and chief operating officer, and an engineer, no surprise, an engineer with 30 years of experience in team leadership, manufacturing, process development, engineering, etc. across Europe, UK, and Asia. And yeah, we have to say Europe and UK, as UK is no part of it. It's a different topic, but we're not going to dive into that. Passion about engineering solutions and circular career. Interesting. Welcome, Guy.
That's good. Okay.
Yeah.
Thank you, Edwin. Can you hear me all right?
Yeah, I can hear you. Just before we get started with your presentation, just for my interest, Guy. So how long have you been in the power to heat? When did you get first in touch with this topic?
We've been developing energy storage since 2009. Okay. So a long time, and we started as electricity to heat and back to electricity, and we soon worked out that the economics weren't there for turning heat back into electricity. So it's really been since about 2017 that we've been looking at heat as a storage media for solar.
Okay, interesting. Please take it ahead, Guy. Floor is yours.
Pleasure. Thank you. Hi there, and thank you, Edwin. Thank you, Arina. I'm Guy Win Stanley from Caldera Heat Batteries, and I'd like to introduce you to Caldera and give you an insight into the potential that industrial heat energy storage deployment with solar can offer. It's moving forward on a slide. I said I had to be patient. There we go. Heat is an essential ingredient for many production processes, from brewing beer, pasteurizing milk, dyeing clothes, or sterilizing medicines. Heat accounts for close to half of all energy consumed in the world, and of that half is domestic, with the other half industrial. The industrial sector requires hotter temperatures than domestic, and displacing this has been one of the greatest challenges to industry as it shifts towards a greener path. Businesses are desperate to escape the volatile energy costs and are under enormous pressure at board level to hit net zero. Energy storage unlocks cheap energy from on-site solar, especially now given the plummeting cost of solar, and in the case of Caldera, not having to connect to the grid. Caldera get away from the need to connect to the grid by creating a separate microgrid with connectivity to the main grid only to its existing size, and has the ability to absorb all of the solar loads directly into its storage. This, of course, means no waiting for costly grid infrastructure work on solar projects. Now, a 20 megawatt solar array can now work with a 1 megawatt site to grid connection. Each of these bars represents the percentage usage at increasing temperatures from 100 degrees C all the way up to 1700 degrees C for the whole industrial heat market. Caldera targeting the orange 100 to 200 degrees C heat requirement, which covers all of the processes in industries I've just mentioned. Interestingly, below 90 degrees C is well within our capability, but as Arina has pointed out, a heat pump may be more suitable. If you go higher, you go to specific industries, such as in the middle there, 900 degrees C with cement production, and at the end, 1500 degrees C with glass and steel. The ideal target for Caldera is between the 100 and 200 and represents 19% of this energy storage market, which is large. It consists of most factories with steam networks providing up to 14 bar steam and 200 degrees C, and heat processes easily covering pulp and paper, pharma, textiles, brewing and distilling, food processing, and waste-to-water treatment. Caldera have developed a commercially viable product that can be easily deployed and scaled, and we're looking for early sales. Our systems are modular and expandable. We locate them close to where the heat is being used, transferring the solar field energy using high voltage electric cables directly to the stores. Each store can provide 4 megawatt hours of storage, charging at 1 megawatt and discharging at 650 kilowatts. We combine multiple units to create larger storage systems up to 200 megawatt hours with the ability to absorb 50 megawatts of power. The whole storage system is around 1/3 of the cost of electric, that's lithium-ion batteries. What I'd like to do now is take you through a business case, which is a factory we've been looking at within the UK, where we can say that even with the British sunshine, we can get a good business case. The example shows a factory with a €2 million per year energy bill that can be reduced to 1.2 million with 5 megawatts of solar and 4 megawatt hours of storage deployment. That's a €0.8 million saving with a 27% carbon saving and a simple 4.4 year payback. Looking at the detail, you can see how the 5 megawatts of solar, 4 megawatt hour of storage, and the cut in emissions there at 27%. Now, if I was to move this factory into Spain, the economics get much better. Clearly, with more solar available in a sunnier climate, we can deploy more solar, that's 7 megawatts, and more storage, there's 12 megawatts, allowing us to get to a massive 73% cut in total emissions and with a better payback. So if I can magically move my UK factory to Spain, I have twice the savings and nearly 3 times the reduction in carbon. And for solar developers, that's more solar deployed. Why this works? Well, let's have a look at the numbers. As we increase the solar deployment for the first 1 to 2 megawatts of solar, we've got no storage at this point, and all the energy can be used directly, either as high value electricity or as direct heat through an electric boiler. At 1 megawatt of solar, the 1 megawatt grid connection can be used to a maximum. On the next bar, at 2 megawatts, the additional power generated can be used as heat, with the high value electricity being used first. Each line of additional solar showing the percentage energy that can be used. And the red shows the losses that are incurred from either clipping at the solar end or heat losses from using the direct heat, but they're small at this point. As we increase the solar deployment, there's good payback when you add more storage with losses ever so slightly increasing. You can see as we increase the solar deployment, the average saving falls on the right here, but the cost is still under the saving and so remains a good commercial payback. As we now increase to 7 megawatts of solar, there is suddenly no longer a commercial payback for additional solar and storage, with savings not covering the costs of additional storage and the solar power now needing to be clipped or thrown away as seen by the red line. We have, however, reached a massive 73% reduction in CO2, and the value of increasing this number further now becomes a marketing one as opposed to a commercially viable one. What we have done is identified that 2.5 to 3 times more solar can be deployed on the site with storage than would otherwise have occurred. And the commercial trade-off for CO2 savings has been identified. So today, I want to leave you with 2 conclusions from an energy storage developer to solar developers for industrial sites. And that is, thermal storage allows 2.5 to 3 times the solar installation that would otherwise have been deployed. And thermal storage allows solar installation without grid constraints, both in terms of cost and time. We're interested in hearing from existing projects with potential to implement early stage storage system deployment. We're in discussion with several sites for first deployment in the UK and Europe. We're obviously looking for projects closer to the UK for better initial system support, but we're still looking for the ideal first deployments. So if you feel you've got something of interest, please don't hesitate to contact us. There we go. Our contact details are here. Please message and contact Daniel, who has unexpectedly been able to join us here today and is also on the panel, or myself. As I said, we're always interested in projects either in the short term, 2025, or out into 2026, 7, 8. So please get in touch. It's been a pleasure speaking today. Thank you for your attention, and I'll pass you back to Edwin.
Thanks, Guy, for very interesting insights in the new world of power to heat with the products of Caldera. So, so you in one of your first slides, you mentioned about the market segments and the application examples. What kind of industries, again, maybe for me and for the audience to know, what kind of industries would be most suitable to apply this kind of power to heat?
I mean, I think initially we're looking a lot at brewing, distilling, food, but there's obviously textiles, pharma, pulp and paper, waste to water treatment's an interesting one. There's a wide variety of industries, especially those who are running existing steam networks. And that's not super special steam networks. That's what I call normal average steam networks running at about 14 bar and up to 200 degrees C of heat.
Yeah, well, breweries, I can expect there is quite a potential in the UK, also in the Netherlands and Belgium, but Spain as well. So, yeah. And this application is more interesting in the Southern European markets with higher solar radiation, right?
Yeah.
So, are you targeting first in the UK before going to Spain, or?
We are targeting first as close to our base in the UK, which is actually right on the southern coast of England. We are probably closer to Europe than we are Scotland, but really we've got a very robust product that we're sort of keen to roll out. And I think just for early deployment, it's easier to be slightly closer to home.
Yeah. There's a question coming in, Guy. So what is the main driver to focus on collaboration with PV rather than considering also grid-connected applications?
I think speed. We've recently upgraded the power on our site here. It's taken us well over a year. It's been very costly. It's very difficult to achieve. And we think for rapid deployment that grid constraints is a major problem and that we can circumvent that.
Yeah. So, and just for my information, so if I'm a brewery owner and I thought, oh, that's a great idea, let's implement this. How much time would it take to deploy such a project and make it operational?
So I think most of the time is all in the planning of the solar field. What we're ideally looking for is solar partners who can build solar, which is behind the meter for themselves. We can come in at quite a late stage and deploy the storage itself and set the system up so that we can convert that solar energy directly into their heat network.
But the building, the contracting of your application, what kind of time frame?
The building an application from our side is probably 6 months. I think there's much longer lead times around planning and potentially deploying of, I say, finance and then the solar fields themselves.
Yeah. Have you come across any difficulties with banks regarding financing this kind of, for them, maybe new application?
I think it's very early stage, and we're working on several ways or several approaches as to how to finance these projects.
Yeah. There's another question coming in. Yeah, what kind of support on site and remote is required for the deployment of Caldera systems?
So on site support is limited. It's a very sort of simple and robust system. Off-site, we've got a control system where we can monitor and develop from afar, so we can give that offer of live data. But basically, they should be fairly dumb systems that get on and do their job.
Okay. Another question coming in. We still have some time. Natural gas costs around 2 to 3 cents per kilowatt hour. Solar PV around 4 to 5 cents per kilowatt hour. And after that, the cost of storing. So integral cost of solar and heat would be higher than 5 cents per kilowatt hour, and so much higher than for natural gas. Why change from gas to solar heat?
Well, I don't know about you, but I wasn't paying that amount of money for gas 2 to 3 years ago. It's very volatile. I do understand if gas is cheap, that this is our big competitor. This is fossil fuels are just so cheap. But if we're going to take ourselves off fossil fuels, we need as cheap an incremental cost coming from storage as possible, which is what we believe we've been able to do. Our cost of storage is really very low. And I think in the future, added to that point is the cost of offshore wind, which granted is coming in from the grid and the North Sea for us in the UK. But more importantly, the cost of solar is coming down to 1 to 2 pence per kilowatt hour from the levels you just mentioned. So we just see it driving down and down.
Yeah. What's your opinion, Arina, about this kind of applications? Do you see a competitive market coming up for this kind of applications?
Yeah, that has been a very interesting discussion. Thank you, Guy, as well, for bringing this on the ground application. It's always very interesting for us to talk directly to the developers and see exactly what is happening on the ground. I took note on the fact that thermal storage is very important. This is also one of the things that we try to, because thermal storage is not a new technology, but it has not used so much in the past. So it can provide a lot of flexibility and security, and can also decouple it from the grid and be able to have more independent applications, as you are saying. And I also took note on the fact that you mentioned that it's difficult to connect to the grid because it's very congested, the grid, and there are very high fees to connect to the grid. And this is also what we are promoting with the innovation in system planning and system operation, and how these things should change to enable this innovation, to make it easier for this innovation to pave the way and to become more cost competitive. Because of course there are burdens, and probably today gas is cheaper, but if we look in the future and we want to be independent of exports and or imports of gas, and to reach our climate targets, there is support needed to pave the way to have these renewable based solutions completely competitive
Yep.
and
Where would
affordable.
what do you think is the biggest threshold? So if we need to multiply this market 10 times in the coming 8 years, no, it's only 6 years left. How we're going to do it? What needs to be done? Is it the government that needs to change regulation? Is it the industry to scale up? Is it what needs to be done?
From my side, it's industry to scale up. I believe with our technology, we want to see a couple of very successful early deployments, which we're looking to 2025 for. And then immediately on seeing that successful rollout, I think there'll be a sharp increase in demand. And then really it's a question of how quickly we can scale production, which is we're confident on, but it's finance and implement into industry.
What about your
Absolutely.
opinion, Arina?
Yeah, we always say we see technologies here. It's more
Yeah.
how to scale it up. And the production lines and supply chains are also a big question, because one thing is to have the heat pumps or I don't know whatever technology ready, and another one is to produce it and scale up immensely. This is something that needs to be unlocked as well. But technology is here, so we need to, yeah. I think industry, but also from the regulatory side, we look at the power system in a very old way, and we need to innovate a lot and to enable innovations to come in by permitting, making faster the permitting, decreasing the connection fees, or I don't know. There are many different things that are old in the way we look at the system and the regulation, and this needs to advance in order to allow this new innovation to come.
Yeah. Well, I think it's also spreading the word, right? Because if the payback times, as Guy presented, is between 3.5 and 5 years, that should be very attractive for any industrial stakeholder to implement this. So then it's probably also the promotion, the marketing, even from this of this kind of new technologies.
Yes. And I was going to say, my background is very much manufacturing and supply chain. And we've had that at sort of the very front of our thought for this technology. And it is surprisingly simple and robust with a quite a sort of low tech supply chain. So we will be able to turn that up quite rapidly when the time comes.
Yeah, there's another question coming in for you, Guy. Where it's not possible to co-locate solar, does your technology work with time of use grid tariffs? And if so, how does the economics stack up?
So it does work with time of use tariffs, but you're buying much more expensive electricity from the grid, or potentially. I think we have to look at the economics on a case-by-case basis, but you do have to be connected into the grid. So it's a slower project to roll out, but nonetheless, if the economics are there, our storage will happily take in, off-peak electricity and utilize it as heat. But I think for us, the value of heat is, let's just say, 8 to 9 pence per kilowatt hour. And if you're buying it in at sort of something just under that, then the economics might not be all that great. But I think we have to look at it on a case-by-case basis.
Yeah, but does that require any software that is taking into account the actual grid?
The software and control is very, very straightforward. We've done it on our products in the past. It's really about having a control strategy in place as to when you want to charge. So whether it's time of use charge, when a price on a market goes above a certain price, whether it's fixed periods of time, whether it's controlled manually, that there are a number of strategies, but they're very, very easy to implement digitally.
Okay, final question from my side for both of you. Where do you think we will be in 1 year from now if we would do this webinar again? Guy, what do you think?
I'd hope that we can have the webinar with behind me a nice big store deployed on a site, running nicely, where I can tell you all the benefits and how easily it's gone, although that's always a tall order. But hopefully demonstrating actual real deployment.
Cool. Arina, your final words. Where do you think we will be in 1 year from now?
I hope the same, because we're looking at developers and that industry to advance. So I hope whatever Guy says, it comes true. Yeah.
Okay, so this will be then an open call to any developer to start using these technologies and showcase their examples next year in a new webinar. Let me thank you both, Guy and Arina, for your lovely presentations. Sharing my last slide, our upcoming events here you see on this slide, and will also be shared in the slide deck. Thank you very much for joining. I look forward to seeing you in some next webinar very soon. Thank you. Bye-bye.
Thank you.